Live streaming is on.
Ramesh, you can start off.
Yeah, good morning, everyone. We welcome you to the ARSI monthly webinar series conducted every first Sunday of the month at 10:30 a.m. in the morning. Today we have the second part of the presentation, by V to JEK, Nitin, and V to WMY, Mani, on the AMSAT India. This part of the program will have probably a live demonstration of the satellite tracking and receiving the telemetry or the beacon. So this program will be for 1 hour and also will be recorded and will be available on YouTube from tomorrow. Thank you very much. Please take over, Madhu, and you can introduce the presenters.
Okay, good morning to all. We are continuing the series with AMSAT India. Last month we had the introduction to AMSAT India, where we had Nitin, the secretary of AMSAT India, and Mani, V2WMY, who is in charge of the Director Educational Outreach Program of AMSAT India. So we welcome you all to the session, and I'll pass it on to Nitin so that he can start off the session. All yours, Nitin.
Okay, thank you, Ramesh, and thanks, Madhu, for providing this opportunity. So myself and Mani VU to WMY, we are here on this to share about a beginner's guide to amateur radio satellites. This is the part 2 of the webinar. The first one was an introduction to AMSAT India and the activities and all the heavy lifting that we are doing from AMSAT India. So I'll start sharing my screen. Let me know once you guys can see. Is it visible?
Yet to come up.
Okay. How about now?
No. You have to go into full screen now.
Okay.
Yes.
Is it okay?
Yes.
Okay. So good morning, everyone, and thank you all for joining this webinar. And as I mentioned earlier, this part we will actually cover about beginner's guide to amateur radio satellites. And this is the agenda. Again, I just want to briefly touch about AMSAT India and the office bearers. Some of you must have not joined on the first webinar. So just want to touch upon that to introduce about AMSAT India and the office bearers. Then an introduction to communicating via satellites. Then we can have some discussions. Of course, I know that you will have to post the questions on YouTube, and Madhu will read it out. We can have a discussion as well, and or a Q&A, whichever is okay. So this is about AMSAT India, again a non-profit and a non-governmental organization involved in design, development, and launch of amateur radio satellites in India. And the primary objective is to promote satellite communications among the Indian amateur radio fraternity and also the young generation. So AMSAT India was initially formed as a very informal group, a satellite working group in the year 2000 by a few like-minded people, and then we later formed this it was restructured in 2004 as AMSAT India with an organization with wider goals and primary objectives, and also to engage with ISRO educational institutions to design, develop, and launch amateur radio satellites. We are based out of headquartered in Bangalore, and this is the only national body and the focal point in India recognized by AMSAT International and also other AMSAT organizations worldwide. So that's about AMSAT India, and these are the office bearers. President is Ramesh Ramsubbu, VU to RMS. Vice President MS Giridhar, VU to MGD. I am the secretary. Of course, my call sign has changed now. It is not VU3TYG, it is VU to JEK. Treasurer is Venkatesh Kata, VU3 ICC. We have Director Educational Relations, BA Subramani, VU to WMY, who's also there on this call today. We have Technical Director, it's actually TBD. I had to change that. And then we have technical committee members, Ganeshan, I think most of you know, VU3 GEK, Ravindranath, Dr. Ravindranath, VU2 RVJ, Somshekhar Kumar, VU2 HCJ, K Balaji, VU3 Papa Zulu Alpha, Somshekhar, VU3 JBA, and Air Commodore V Subramaniam, VU2 UV. And Director for Regional Coordination is Somshekhar, VU3 JBA, and we have regional coordinators. In the north, we have Kaustav Saha, VU2 Triple U, and in the west, Rajesh Wagadia, VU2 EXP, and I also handle the public relations for AMSAT India. So I put in this slide. I don't know if there are any SWLs today who have joined. So I don't think this will be of much relevance, but just want to touch about what is amateur radio. Again, amateur radio, also known as ham radio, is a hobby that allows individuals to communicate using radio frequencies. And the purpose is self-training, emergency communication, and experimentations. Again, the key point to remember is non-commercial communications and operated by licensed individuals. Okay, before we go ahead with the main agenda, I think most of us we are active on HF, and we all depend on the sunspot cycle. Knowing that long distance communication, how the sunspots influence the long distance communication on high frequency. So again, what I'm trying to say over here is to have fun without sunspots, and that is satellite communication. And this slide, actually, this data I pulled it from the Space Weather Prediction Center just yesterday, and I think most of you know that we are currently in the solar cycle 25, which means that the HF propagation conditions are generally improving due to the solar activity. But again, if you look back, with all the sunspot cycles, the HF propagation was not that great, and that is where you can have fun without sunspots using the amateur radio satellites. Okay, so what are amateur radio satellites? So amateur radio satellites, they're also called as Oscars, orbiting satellite carrying amateur radio. And these are the satellites that are launched into space to provide radio communication services to the amateur radio operators. And these satellites are launched, by AMSAT organizations worldwide. Now we have many of the educational institutions which are building satellites and using the amateur radio frequencies, and they're also incorporating some of the amateur radio payloads into their satellites, right? And the key point to remember is the amateur satellites, they use the UHF, VHF, and the higher frequencies that are allocated for radio hams worldwide. And they act as a communication relay between radio operators on Earth. So what you see over here is some of the images. On the left, what you see is the AISat, which was built by AMSAT India and Exceed Space launched in 2019. Then you have the AO40, which is a highly elliptical orbit satellite in the photos over here. So next, what I'm going to talk about is having fun with the amateur radio satellites. Just like how you have fun on HF, building antennas, chasing DX, awards, things like that. Similarly, with the amateur radio satellites, there are a lot of things that you can have fun with. for example, technical achievement, working DX and grids, activating DX and grids, and then you have ARRL VUCC satellite awards. There are also awards that are issued by AMSAT organizations worldwide. And the last one is recognition from satellite builders for telemetry decoding. So these are all the fun aspects of working through amateur radio satellites. And I want to give some examples on this. For example, for technical achievement, what you see over here is a linear transponder and a CubeSat com system that is designed and built by Ganeshan, VU3GEK. What you see on the left is the UV linear transponder and the CubeSat communication system. And similarly, from a ground point of view, this is something that will go to space. From a ground point of view, you can see, designing and building antennas to communicate through the amateur radio satellites. The one on the left is done by a DXAM, and on the right side, what you see is a VHF and a UHF stacked antenna designed by VU2 KGB and his harmonic. If some of you might remember, this was actually displayed in the Cochin Hamfest. So these are the kind of things that anyone can achieve with their skill set, what they have from a technical point of view. Okay. Then I mentioned about activating DX and grids. So when we are communicating to the satellite to qualify for some of the awards, we need to contact multiple countries, multiple grid locations. So that is where some of the people who are active on the amateur satellites, they go and activate these DX locations and grids. And what I'm sharing over here is our own Gopan, VU3 HPF, who succeeded in making the first contact from North America, where through the QO100 geostationary satellite, and it was almost at the edge of its footprint, and it was almost outside the coverage area of the QO100. And he was at a location called as Signal Hill, and which was just below the horizon at minus 0.9 degree. And he had the first transatlantic contact with David G0 MRF in southwest London. So these are the kind of efforts that are put in by those people who are active on amateur radio satellites, and those who want to in the future. This is going to be one of those fun areas. And then I spoke about activating DX. So you can go to various locations, grid locations, and being having some portable equipment, you can activate these from DX locations. What you see over here is view to KOC Om Prakash. He was QRB on satellites for the ARSI field day some years back from a hilltop near Belgaum. And then satellite awards, right? Like what I mentioned about grid locations, working countries. There are awards that are issued out by ARRL, by AMSAT organizations worldwide. So what you see over here is the accomplishments of our own lucky VU2 LBW, who has several satellite awards, by working through the amateur radio satellite. The first one, what you see is is presented to him for having made two-way contacts with amateur radio stations in each of the 6 recognized continental areas of the world, and that is WAC Worked All Continents Award. And on the right side, what you see is the Japan Century Cities Award. This is again it's given that he has communicated with at least one amateur radio station in each of the 100 cities in Japan. So you can imagine the patience and the efforts that are required to look out for these stations through the amateur radio satellite. And then, of course, the ARRL VUCC award. So he has communicated grid squares on the frequency band indicated. And then the WAJA award, that is Worked All Japan Prefectures Award. So there are very interesting, awards, and of course, this requires a lot of dedication and efforts, and also the right setup to be able to do this. But this is again a fun part of amateur radio satellites. And then the last one was recognition from satellite builders for telemetry decoding. So every satellite needs to send its health parameters to the ground, and that is where we radio hams, or people who are interested in amateur satellite, they listen to these telemetry signals and decode those telemetry signals and send it back to the project teams, and they in exchange send us a QSL card, something like what you see, what I'm sharing now. One which I got from Japan for the Kashiwa satellite. And this is the call sign of the satellite, JS1YMX. This is the call sign of the satellite. And then we also have something over here, the Andy D Orbit Award. This is received by Mike Rupert, DK3WN. And this is a Hirogari satellite for which the QSL card was sent. So this is also a fun part. I'm going to cover about telemetry decoding in the upcoming slides. And this is also a fun part of it. What you see on the screen over here on the left side is a certificate that I received from Roscosmos, which is the equivalent of ISRO, the Russian space agency, for having participated in a shadow beacon experiment from the International Space Station. And I submitted a report on the observation as a field station. So you can see a certificate that is sent by post from Roscosmos to me and signed by one of the Russian cosmonauts. So this is a great thing to have on your wall as a wallpaper. And also on the right side, you can see a QSL card from a Russian cosmonaut, Romanov Romanenko, who actually sent this QSL card when I participated in one of the experiments for the Digipiter mode from the International Space Station. And then talking to Richard Garriott, when he was in space, the first private space tourist, he was very much active on ham radio from the International Space Station, and a QSL card from him. So this is also a fun part of it, getting these kind of certificates and cards. Now, coming to history of amateur radio satellites, the key milestone that we need to remember is the first amateur radio satellite, Oscar 1, was launched in 1961, completely built at the backyard of some of the people in W-Land. And in 1983, the first amateur satellite with a transponder for voice communication was launched. And I do want to cover about there are dozens of satellites that have been launched and operated for amateur radio use. There are hundreds of them, which can be used in one way or the other. And the importance of this is amateur radio satellites open new opportunities for global communication and experimentation. Okay, so this is a brief history. There is a lot of information about amateur radio satellites on the internet, which you people can Google and look for more information. So coming to the types of amateur radio satellites, again, we have satellites based on the orbits, right? So first one is about with respect to the low Earth orbit, we call it as a LEO satellites, and they move quickly across the sky, 90 minutes per orbit, and it is mainly common for voice, packet, and digital communication. And they are less than 1,000 kilometers, but they can be as low as 160 kilometers as well. 160, we also call it as a very low Earth orbit as well. So this is normally the orbit of the LEO satellites. Then we have the geostationary orbit satellites, which we call it as GEO. They are positioned over one point on the Earth, and then it's always visible to us. We don't have to turn the antennas, providing continuous coverage of specific regions and they are at an altitude of 35,000 kilometers above the equator. So these are the geostationary orbit satellites. Then we have medium Earth orbit satellites. This is between the LEO and the GEO with some intermittent coverage. And the orbit of a satellite between LEO and GEO, MEO satellites orbit the Earth between 2,000 and 36,000 kilometers. And some of the examples over here, I'm just giving an example for a LEO orbit, the satellite, which is our own AMSAT, VO52, roughly about 520 or 540 kilometers. And then for the GEO orbit, all of you know about the QO100, which is in the GEO orbit. And then for the medium Earth orbit, we had AO40. Unfortunately, very few satellites in this orbit. Again, GEO also is the same. QO100 is the only satellite in the GEO orbit which amateurs can use. And in the medium Earth orbit, it was AO40, which stopped functioning. And the other successful satellite was Green Cube at about 6,000 kilometers, and was very actively used by amateur radio operators worldwide on the digital mode. And recently, even this went QRT because of the high radiation that that is there in the medium Earth orbit. So these are the different types of amateur radio satellites, and you can see on the right side a pictorial representation of the three orbits. Okay, as we speak, there is a satellite pass right now going on. Let me quickly switch over and see what is happening over there. I'm trying to decode the telemetry from that satellite. I don't think I've received anything. Just give me a moment.
Then it's already 8 degrees elevation.
Oh, okay, Mani. No, it's yeah, there is a signal, but I think okay. Can you all is my sharing visible?
Yes, Nathan.
Okay, we'll just give a couple of seconds for this. Yeah, there is, but some reason it's not recording. Okay, let this run in the background. If it decodes, then I can share back again. Let me go to the presentation. Is it visible?
Yeah, make it full screen.
Okay. Okay, so we were talking about the orbits which I covered. Then how does amateur satellite works? I'm just going to give a very basic representation of that over here. It's a basic operation. A radio operator transmits a signal to the satellite, and the satellite relays the signal back to Earth, allowing communication between distant stations. Okay, and then we have the transponders. That is what we call as the payloads in the satellite. And most of the amateur radio satellites have transponders that act like repeaters, amplifying and retransmitting signals. Okay, this could be analog, this could be digital. There could be also one-way transmissions that are happening. So that is what these transponders do. And the frequency that we use is what is allocated to amateur radio by various countries. And the common frequencies are 144 to 146 in VHF, and 435 to 438 in UHF. And of course, there are some satellites which use higher frequencies as well in the L band and S band. So how do we get started with amateur radio satellites? One is what you need is a license. You must be a licensed amateur radio operator. then what equipment do you need? A transceiver capable of VHF, UHF frequencies and modes like FM, CW, and SSB. This is basically based on the capability of the satellite. If it is just a FM satellite, all that you require is a FM radio. It can be a handy, it can be a base station. But if a satellite is having a inverting transponder, which can actually where you have to use only single sideband, then you will need a all mode radio capable of LSB and USB. And if you are interested only to receive signals, to monitor signals, then all you require is a SDR, a software defined radio. There are various models available, right from a very low cost ones to a highly expensive SDRs. And then an antenna suited for satellite communication. There are many radio hams who use very simple antennas, right from a whip antenna on their handheld to communicate. But if you really want to enjoy, then you require a good antenna suited for satellite communication, like an Yagi antenna or a handheld directional antenna. You will require that, and of course, rotator if it is possible to have. Otherwise, with simple handheld antennas, you could communicate via many of the amateur radio satellites, mainly the FM satellites. And then you require a PC or your phone or your tablet for basically having the satellite tracking software uh, to see what time the satellites are visible to you and their footprint, their frequencies, and things like that. So these are the very basic things that you require to get started with the amateur radio satellites. So basic satellite communication techniques. So one is first thing is the tracking satellites. Learn how to track satellites, their orbits, and find out when they will be visible in your location. So as I mentioned earlier, there are tools like sorry, what I meant was there were tools like Orbitron, Heavens Above, and n2yo.com are helpful for tracking satellites. So all you'll have to do is basically install these applications on your PC, on your phone, and then select the satellites, and then you should be able to track this. The satellites are also, they need to be, the Keplerian elements need to be updated. So this is something that is provided by an organization called as NORAD. They track each and every space object, and the satellites are basically available. If you can look at the screen over here. So this is Orbitron. This is a satellite tracking application for Windows. And as you can see, I was just tracking a satellite called as Hades. And here you can see on the right side, these are all the amateur radio satellites which can be tracked. So if I select all these satellites, you can see the number of amateur radio satellites that are currently orbiting, right? And at any point of time, one or the other satellite is available. For example, this is my location here, and you can see JYSat-1 is visible to me. Okay, there is one more satellite over here called as ISAT. This is visible to me, that is AO27. And then you can see the footprint of the satellite as well. So these kind of applications will help you to track the satellites and understand some of the orbital parameters. For example, if I click on JY1SAT and the data over here, you can see that the altitude of this satellite is almost about 511 kilometers, right? And the range of the satellite from my location is almost about 1,900 kilometers. And you can see the various other parameters over here with respect to the orbit of that satellite. And similarly, we can also see what frequencies these satellites are working on, which we can work on. So if I go here, I think it's not updated. So some of these satellites will also have the frequencies listed. For example, if I just select ISS. Okay, so if I select ISS and if I select on the rotor radio, you can see the various frequencies that is being used by the ISS for amateur radio. Okay, so these kind of software applications tools, you can install it, and then that is going to help tracking the satellites and the footprint, and we can start working through the satellites. Operating mode. So FM mode for simple voice communication. As I mentioned, most of the satellites we have a FM transponder, just like how you work a terrestrial repeater. This is nothing but a repeater in the sky, right? So it has uplink and a downlink. Normally it is VHF uplink, UHF downlink. But now as the VHF band is getting crowded on the satellite segment, now mainly some of the satellites they're using UHF uplink and VHF downlink. Then you have single sideband. Basically, these are satellites having a linear transponder, which is between say 40 kilohertz to 100 kilohertz bandwidth. So multiple users can use this linear transponder. Unlike FM, it is a single user, right? You'll have to wait for your turn. But using SSB on a linear transponder, multiple users can actually communicate via such satellite. And the linear transponders, the global alignment and agreement is that we use only single sideband and not FM because of the power considerations and things like that. And then digital modes. There are satellites where you can use digital modes like PSK31, FT8, and also text-based communication. Like what I mentioned about the Green Cube satellite, which was there in a medium Earth orbit, that was actually using this text-based communication. Okay, and tracking software, as I shared earlier, Orbitron is one of them. There are many other softwares that are available based on whether you're using a Windows PC or a Mac or any other mobile device. You could install this tracking software on your devices. Mani, you want to talk, give some more pointers about tracking?
No, go ahead, Nitin. It's
Okay.
fine. Go ahead. Good. I'm just listening. Go ahead.
Okay, tips for successful satellite operations. Let me make it full screen. Well, first one is the antennas. So it's very important to point the antenna at the satellite for the best signal, right? So we will have to point it both from an azimuth and an elevation point of view. So if you are using a handheld antenna, you'll have to point it at the satellite for the best signal, and use tracking antennas for better performance during satellite passes. So one is the manual way, the other one is using a azimuth elevation rotator system, where you can connect it to your PC and the tracking software, and this will automatically guide the antennas to look at the satellite right from AOS, acquisition of signal, to loss of signal. So this is going to be very efficient as well, and also better way to communicate through the satellite. And then the timing, just like what I showed earlier on Orbitron, know the satellite's orbit and ensure that you are ready when it comes into range. So you can put up some reminders, tones and things like that, so that you get an indication that the satellite is coming into range. Some of the common challenges that we have is limited time window, like what I mentioned earlier, especially for the low Earth orbit satellites. It's a 90-minute. So the window that you get is hardly, it depends on the elevation. It could be as low as 8 minutes to about maximum 15 minutes, slightly less than 15 minutes. But if you look at some of the other orbits. Like if it is a geo orbit, then like for QO100, you don't have any issue. You can communicate through the satellite 24/7. And then the signal degradation due to atmospheric conditions, just like what you have seen in your home when you're using the DTH, and if there is a heavy rain and things like that, there are sometimes there is a disruption. But since we are using VHF and UHF, there will be a not very significant degradation, but we could also experience those degradations due to atmospheric conditions.
Anything?
Etiquette. Yeah, Mani, go ahead.
I would like to just add another point here. The another one is about the challenges. Here, unlike the terrestrial repeaters, these satellites, they keep moving. That means the footprint is also it's a moving footprint, and source the satellite, the repeater, the transponder. When it rises, it will be at the farthest, and when it sets, it will be at the farthest. And when it is at the TCA, time of closest approach, it will be closest to us. So that means one has to get familiarized with the Doppler on the both the ways. Whether you're transmitting and receiving, we have to have the correction for the Doppler in the frequency, and also varying power levels. So when the satellite is in the horizon or at the low elevation, so if somebody is uplinking, definitely they have to have little more power pushing, and then when it comes closer to us, and just to avoid desensing the satellite, we can reduce the power level, and then so vice versa. So this is also one of the challenges, of the common challenges one has to get familiarized while operating the satellite. Go ahead, Nathan.
Yeah, that's a good point, Mani, and thanks for bringing that up. So I just want to show over here, how that Doppler compensation is there. Now I have selected a satellite over here, Hades R. But anyway, I will have visibility of the satellite at about 12:17 p.m., 1 hour 10 minutes from now. So here, if you see, I have selected a frequency for the satellite. The downlink is 436,888. So when I select this frequency, you can see here on my SDR, the SDR that I'm using. Let me how the Doppler compensation is happening. That's what Mani was talking about. So see, can you see here the frequency changing? So this is actually what Mani was talking about, the Doppler correction. And this is completely automated. But when you are using a FM satellite, you will have to manually compensate for the Doppler. All you can do is store those frequencies in various memories, and then toggle between that memory to give that 5 kc um, Doppler correction. Mani, you want to add anything on this? Was this
No,
screen
Nathan, go ahead.
visible? What I was sharing on the SDR
Yeah,
plus
yeah,
plus?
yeah, yeah. It's visible.
Okay.
Go ahead, Nathan. It's
Okay.
perfectly all right. Go ahead.
Okay. So that was about Doppler. Go back to the presentation, and yeah, that was about the common challenges that we face. And then I also want to emphasize about the etiquette. When using the amateur radio satellites, it's very important to follow proper etiquette to ensure the smooth and respectful operation for everyone involved. Right. So here are some of the guidelines while communicating via amateur radio satellite. Be aware of the satellite paths. Right. So the satellite orbit and the Earth are not always visible or in our range. So use software like Orbitron, Heavens Above to track a satellite and when it will be visible in your location. And only transmit during a satellite pass and when the satellite is in range. Otherwise, you could be interfering with some other satellite. Of course, there are satellites which are also sharing the similar frequency. And then listen first before transmitting. It's always important to listen for ongoing communication to avoid interfering with users. Satellite channels can be crowded, especially on popular satellites. So be aware of ongoing conversations or data transmission. But if you look at the activity here in India, yes, it is picking up. There are a lot of people who are active on the FM satellites. And also, as the satellites, if there are low elevation passes, you can hear many stations active from the Southeast Asian countries. So always listen first and it'll this will actually make sure that you are also able to have a two-way QSOs with the other hams. And limit your transmission time. Be concise and efficient communication. Amateur radio satellites, they have a typical bandwidth, so it's important to be brief and to the point when making a contact. Ensure that you don't monopolize the frequency by talking for too long. Again, since it's a very short duration pass, normally what we do is we just exchange the call sign, the grid locations, and if there is no significant activity, then it is still okay to have a slightly longer QSO. But if there are other stations, we can't have a RACU on a satellite. But if it is something like QO100, definitely yes, there is the bandwidth to have a long RACU on the QO100. So popular amateur radio satellites, I did not list everything. This is a live dashboard from this particular link. You can go and access it over here, and you can see the different satellites which have been heard by radio hams. They actually go over here and update this, and this is a live dashboard to see which satellites are active and on what frequencies. So you can look up this information. There are other resources also available where you can see which are the popular amateur radio satellites, their frequency, and their mode of operation, right? So this is also an interesting page where you can look for the popular amateur radio satellites. The other one very popular that you can use is the International Space Station. I think all of you know that right from for a very long time there has been this ARIS program, amateur radio on the International Space Station, where there are ham radios set up in the International Space Station, and then it has been used by various cosmonauts and astronauts from the space station. So similarly, the International Space Station has a crossband repeater, and it is currently active. The status of the payloads can be obtained by visiting ARIS website, and currently the crossband repeater is active. It is the uplink is on 145.990, and the downlink is on 437.800 FM. And you can hear a lot of stations from India active on the crossband repeater. And this is the simplest thing that you can try. Again, you could actually try this with a simple handy with the one with the whip antenna. But if you really want to get through the crossband repeater, you can use a Yagi, a simple Yagi with 3-element VHF or a 5-element UHF. With even, and the power recommended is not high power. You could use low power of about 5 to 10 watts. You should be able to get through the ISS crossband repeater. And then it also has the APRS on the ISS, where you can transmit your position reports, and it is digipeated from the ISS digipeater and then captured by a ground station and relayed to the internet. So these are the two capabilities, and time to time they transmit the SSTV signals from ISS, which you can decode. And then there are various awards even for reception of the SSTV signals from ISS and some other amateur radio satellites. The other aspect of amateur satellite communication is telemetry decoding. So this is basically one way, just on the listening mode. So telemetry decoding involves receiving data transmitted by the satellite in a specific format, and then the data is interpreted and to obtain useful information about the satellite's health, status, or scientific measurements. So some of the basic steps involved in decoding telemetry from amateur radio satellites is receiving the signal, like what I mentioned, using a radio or a SDR for flexibility, demodulating the signal using software and hardware, identifying the telemetry format, example, if it is a AX25, decode the telemetry data, raw data to usable information, and then verify and analyze the data, error correction and integrity of the data. And then, of course, we have tools and softwares. We have very popular software modems from UZ7HO and hardware TNCs and the SatNOX network. So this is one way, and this is also a very interesting aspect of decoding signals from the uh, amateur satellites. So this is one example. Like earlier, I think I was sharing the screen trying to decode the telemetry from Hades. And this is the same satellite. So this is from a satellite called as Paras-1. This was Taiwan's first satellite, which has a APRS digipeater. And here you can see the SDR++, which is the front end for the SDR. And then we have the UZ7HO software modem. And then this is something GetKiss Plus, basically sending the packets to the SatNOX network. And here you can see the decoded APRS packet from Paras-1. So a lot of these tools and applications are available. Many of the satellite builders, they actually make available software applications which can interface with the SDR and collect the telemetry, and it passes on to the project team. So many such applications are available, and those who are interested in coding, they can actually write their own applications to decode telemetry from the satellites. Satellite communication for emergency services. Again, we always talk about amateur radio being used for emergency services. We have volunteered in many of the critical times. Similarly to that, from a space point of view, satellite communication can be crucial in emergency situation when terrestrial communication infrastructure is down, or for some reason the last mile you're not able to reach, right? And provides a way for amateurs to help with disaster response and recovery. There have been situations where satellites from the low Earth orbit have been used, but as you saw, the typical pass of a satellite on the low Earth orbit is not more than 14 or 15 minutes. But if you look at the capability that we have, like the QO100 satellite, which is in geostationary, you can see the footprint over here. So this provides again a reliable two-way communication during emergency situations because of the orbit of the satellite. So definitely satellites also can be used apart from terrestrial communication for emergency services. So there are a lot of resources if you want to know more about amateur radio satellites, how to work them. There are books available, and also the information on the AMSAT organization's website, whether it is AMSAT India, AMSAT NA, AMSAT UK, AMSAT Spain, and AMSAT DL. A lot of information there. YouTube, there are a lot of videos, people posting about their amateur radio satellite activity. So there is tons of information available if anyone wants to get started with this fascinating aspect of our hobby. Okay, and again, there are online communities. There are discussion groups in India specifically. If anyone is interested, drop me an email. I will get you added to the two popular WhatsApp groups that we have in India. One is the VUSAT group, and the other one is the DO satellite group, where we discuss and share information about the amateur radio satellites. Again, join ham radio forums and focus groups to connect with each other. And in conclusion, again, amateur radio satellites open exciting communication opportunities, and the hobby combines technology, science, and international friendship. And what I request is call to action is to all of you, start exploring satellite communications today. Okay, so that's all I had, Madhu. I think we kind of finished a little early, but I think we can open it up for discussions or questions.
Okay, while we wait for the questions we posted on YouTube, information for those who have just joined in. I have already posted the links for download for Orbitron and the Heavens Above site. Also, the AMSAT status of satellites, the link that Lithium was mentioning, that link has also been posted. And the ARIS.org, those links have been posted for anybody interested. You can make use of those links. And while we wait for questions, still, I would also like to uh, join to the discussion. About 13, 14 years back, we had the. I also was on satellite FM satellites with two handled uh, equipment. One keeping it on VHF, the other one UHF. And those days I was using the Voxen UV KG UV1D. That was the dual battery that we were having those days. And my simple setup was I was using a Slim Jim made out of TV ribbon for VHF, and I had made a what was that called? There was one cable uh, coaxial cable used for the antenna itself. Uh, I forget the antenna. I don't remember. I think I have the photograph. Let me just see if I can share.
Should I stop sharing, Madhu?
Just stop sharing for a minute.
Yeah.
I'll pull up my share screen. Okay.
In the meanwhile, this is view to LU. What are the satellites that anybody can work on a simple omnidirectional antenna, Nathan?
Yeah, omnidirectional. It's okay for some low elevation passes, but still, as I mentioned, it is good to have a simple Yagi, a handled Yagi. You can use some antennas like a J-pole, even a Slim Jim. Any of these antennas can be experimented, but preference would be for a directional antenna.
But this money here, V2WMY, as Nitin told, a Slim Jim or a J-pole with about 20-25 watts should be okay. But if you go for a Yagi, directional high gain Yagis, 5 watts is more than enough, even for low elevation work, Ramesh. Go.
Okay, thank you.
Okay, this is the picture of my Slim Jim made out of TV ribbon that was taped onto a PVC pipe, and this was laid down horizontal instead of vertical. I put it horizontal, and I was able to work ISS. I was able to work VO52 and a few other satellites. And this is the bazooka. I just remembered the name now. This is the picture of the bazooka that I had made for UHF. This was mounted vertically. This was mounted vertically for UHF. So with simple setups like this, we were able to work the satellites. Of course, those days my cable length was very short. I had to go up to the terrace to work them, and there have been times when I was sitting under an umbrella trying to work the satellites. Uh, so makes fun, and it's not really very difficult to get onto the satellites. So this was my experience with satellite working there.
Yeah, here, Madhu, you said you are oriented as a vertical. It's good, but most of the time, the horizontal polarization works best for the satellite work. Even a simple dipole, V dipole. I know the main reason is most of the man-made electrical noises are vertically polarized. So in that way, that will avoid if you just orient your antenna towards as a horizontal polarized one. And whereas from the satellite, it's not just like whether it's a vertical or a horizontal, because it all depends upon the antenna orientation and the attitude of the satellite. So the best one would be a circularly polarized antenna with the LNE. That would be the most ideal. But to make things simpler, it's a simple dipole. The horizontal configuration should work very fine. Over.
Okay, right. Thanks for that information, because these were the initial days of my satellite working. So I was just trying to experiment with that. Okay, we have got a couple of questions that have come up on YouTube. View to Charlie Hotel Delta wants to have any links for homebrewed antennas.
Yeah, sure. There are many such articles available. Depends on what kind of antennas you want to build. If it's just a simple, VHF, UHF on the same boom, like what I'm sharing right now, this was one of my first antennas that I used, for working through the FM satellites. Or you want to build something like a omnidirectional antennas with the right-hand circular polarization. It's called as egg beater antennas. Then turnstiles. There are various, antenna designs available on the internet. If any specific thing, you can drop me an email and I can share some information. I can put my Madhu, you can put my email address on the
Okay, right,
chat.
I'll do that. Aditya. And there's one more question from RR Balasundaram. He's not put in his call sign. Is there any restriction on download to download weather satellites NOAA?
Mani, you
Is
want to take
VU
that?
yeah, is VU3 TRF. RTF is Balasudram is VU3, VU2 RTF, and no, as such there is nothing. But recently InSpace told that we should not distribute it, but absolutely there is no any such restrictions as of now that one should not download weather images. So we can receive the live weather images from low Earth orbit satellites like all the three Nova 15, 18, and 19, and also the Russian Meteor M23 and M24, and also there are a couple of geostation satellites which transmit beautiful weather images from 36,000 kilometers, the full disk of the Earth. So there are a few Korean and Chinese satellites. So we can download even those images from geostationary satellite. To begin with, one can begin with just a simple V dipole, and then they can further develop their skills to develop a really high gain antenna. Here the problem is if you're going for a very high gain directional antenna, the pointing accuracy is very very important. So definitely it will call for a azimuth elevation two axis rotator. So it's better they can go for omnidirectional antenna with a LNE. So that would bring down the cost. Is that a Roger, Madhu?
Okay, QSL. Thank you, Mani.
And
Uh,
just to add to Mani, right? So can you see my what I'm showing on the camera here? Can you all
Yeah,
see?
yeah,
So
I
this is
can see.
basically a 3D printed L-band antenna for weather satellites, which I'm currently building. So these kind of antennas are very simple to make. As Mani mentioned, you can start with the simple V dipole, and then you want more gain and things. You can actually build these kind of antennas for weather satellite.
okay, one more question has come up from Shripal. How does the integration of phased array antennas in satellite communication systems enhance signal quality and reliability?
Yeah, definitely yes. But in the amateur radio segment, we have not seen that, especially if we are going to use higher frequencies, then yes. But it's mainly on higher frequencies like S band and above. Money, you want to provide some insights on that?
Yeah, you're right. As of now, none of the amateur radio satellites even can think of going for a phased array antenna. But we have the phased array antennas for the synthetic aperture radars. And so where you can electronically steer the antenna, the beams, rather than having a mechanical system. So that is how it's been accomplished now. So you have multiple antennas mounted on a dome, and so that can be you can change the phases, and even you can steer the antenna pattern, the beams, and that is how this has been accomplished. But this is also a little bit complex, but compared to the mechanical way of steering the antenna, this is always preferred. Over.
Okay, Shripal is way to Sierra Papa Mike. Okay, we are coming to the end of 60 minutes that we usually schedule. Is there any other questions or queries before we close the session?
And Madhu, Balu is very active on the weather satellite.